In this video, we are going to discuss limiting reactants. That's where one reactant is going to be used up first and therefore will limit the amount of product that will be made in the reaction. The other reactant that is not the limiting reactant will be in excess, and you'll have extra left over that was unable to react because there was nothing of the other reactant left to react with it. So here we're considering the combustion of propane. We have propane plus oxygen is going to produce carbon dioxide and water, and here we've already balanced the equation. That's always the first thing that you want to do, is balance the equation, because that tells you the molar ratio. So if we have 50 grams of propane and 30 grams of oxygen, we want to know which will be consumed first. Is all of the propane going to be consumed or all of the oxygen? To do that, we have to find the number of moles of each one. To find that, we divide each of the given amounts by the molar mass of that substance. So here we have 50 grams of propane divided by 44.09652 grams, and we get 1.133 mole. And for oxygen, we have 30 grams divided by 31.9988 grams. That will give us 0.937 moles of oxygen. Now, this isn't enough to tell us, because you can see that we do not have a 1-to-1 ratio here. So just because there are fewer moles of oxygen doesn't necessarily mean that it is a limiter. So we have to find how much oxygen propane need to completely react and be completely used up. So if we have 1.133 moles of C3H8, and we use our molar ratio to tell us how many moles of oxygen we are going to need in order to completely react all of the propane, we would find that we need 5.699 moles of O2, and therefore that's needed. However, we only have less than 1 mole, and so we do not have enough oxygen. And so oxygen is the limiting reactant. So this is going to be, we're going to put a little star next to it to say that is going to be our limiting reactant. And so we are going to have excess propane, but we are going to use up all 30 grams of oxygen, okay? That means all of our calculations are going to be based off of the limiting reactant, not the propane. So if we want to figure out how much carbon dioxide and how much water we're producing, we are going to use 30 grams of oxygen in our calculations, because that is what's going to be used up in full. There is going to be leftover C3H8, so we cannot use 50 grams because that will not all get used. But since this is the limiting reactant, we will use all 30 grams. So now we can figure out how many moles of propane we are going to use. So we know that if we have 30 grams of O2, we want to know how many moles of propane are we going to use up. And actually, we've already converted this into moles, so I'm not going to do that again. So if we have 30 grams of oxygen, we could convert it to moles again by doing 31.9988 grams over 1 mole of O2. And then we know that for every 5 moles of O2 from our balanced equation up here, we need 1 mole, or we're going to use 1 mole of C3H8, okay? And when we do that, we find that we are going to need 0.1875 moles of C3H8. And we have plenty, right? So we know that this is in excess. And we can calculate how much excess, actually. So to do that, we're going to say, okay, well, we have 1.133 moles of C3H8. We're going to use 0.1875 moles. That means that we have an excess of 0.9455 moles of C3H8. How much is that going to be in grams? So to get from moles to grams, right, we're going to go, okay, 0.9455 moles times 44.09652 grams over 1 mole is going to give us 41.69 grams of C3H8 is going to be left over, okay? So that's how much is C3H is going to be in excess, okay? All right, so again, we have this formula, C3H8, and we want to know what is the maximum amount of water that can form. So how much water, how much H2O is formed if we have, again, 50 grams of methane and 30 grams of oxygen. Okay, so we have to use the limiting reactant. So use limiting reactant because that's what's going to be used up first and limit how much of the water we can make. So again, we know that we have, from our previous calculations, 0.9375 moles of O2 that are used. That's our limiting reactant, and we are going to use our molar ratio to figure out how much water is going to be used. So for every 5 moles of O2, which we got from our balanced equation, we're going to need 4 moles, or make 4 moles of water. And that came from our balanced equation up here, mole to mole ratio, and we find that we are going to be able to make 0.75 moles of H2O. We can convert that into grams, or mass, and we get about 13.51 grams of H2O is possible. Now that's the maximum amount that can be made, and that is what we call the theoretical yield. The theoretical yield is the maximum amount expected to be made. However, let's say that we only made 13.32 grams. Okay, that is our actual yield. Okay, so our actual yield when we did the problem was that. Okay, and so we can calculate the percent yield by doing the actual yield over the theoretical yield times 100, okay? And here we get 13.32 divided by 13.51 times 100, and we get about 98.6% yield. So that's a pretty good yield here. All right, so here are the steps for a limiting reactant problem. And note that if you ever have a problem where you're given both of the reactants, quantities of both of the reactants, so say 50 grams and 30 grams, then you know it's a limiting reactant problem, and you first need to figure out which one is limiting. Okay. So the first thing you need to do is change the mass into moles. You're going to change the mass into moles by dividing by the molar mass of each substance. Here we found the number of moles of carbon monoxide and hydrogen, and then the next thing you have to do is determine which is limiting by determining how much of each reactant would be needed to use up that reactant through the molar ratio. And so here, if we have 2.4455 moles of CO, we know through our molar ratio here, 1 to 2, that we're going to need 4.891 moles of H2. And we can see already that we're not going to have enough there. We don't have enough H2, so that must be limiting. But we're also going to complete the other problem and figure out how much CO is needed to completely react with H2, because that will allow us to then calculate how much excess CO we have. 2 mole of H2, and we see 2.133 mole of CO, and so you can see that we do have enough CO, so this is going to be an excess, and this is going to be limiting. So the H2 is limiting, the CO is in excess. The next thing you can do is determine how much product is made by using the limiting reactant. So H2 is limiting, so we're going to use that in our calculations. 4.266 mole of H2. That's our limiter. We only have that many moles. We're going to make 1 mole of CH3OH, and we're going to use up 2 moles of H2. And so we divide that by 2, and we find that we're going to make 2.133 moles of CH3OH. And we can then convert that into a mass using the molar mass. And we say for every 1 mole, we have 32.04228 grams. And that's going to give us a theoretical yield of 68.346 grams of CH3OH. So that's the basics of limiting reactants. You can figure out which of the reactants limits the amount of product that will be made, and you can determine how much excess you have of one reactant, what will be left over, and you can also then use the limiting reactant to determine how much of the product will be made.